Total eclipse of my heart. I saved every letter you wrote me.
So I was really impressed with how much these students knew. We had a great time here. And now you can once again see the imagery we are pulling in of a white light telescope of two eclipses happening as we speak. These are the partial eclipses, Salem, Oregon, and Madras, Oregon.
Right, as you can see, it's quite an image as that moon continues to progress. Transit is the term over the surface of the sun, getting closer and closer toward totality. And again, this is an opportunity for us to remind folks, regardless of whether you're watching this right now in Oregon or if you're anticipating the beginning of the eclipse from another location in the U.S. or really across North America, wherever you're able to view us from, that it's important that you have to have those safety glasses. We cannot stress that enough. We've been getting a lot of questions on social media, people just emailing us, asking about that. You must have the glasses unless you are in the path of totality and during those brief moments of totality.
Right, and Sean is stressing the glasses, but of course you can also watch the sun indirectly. There are a lot of ways. Nikki Vile, a solar scientist, just told us that you could even pull out a colander because it's got little pinholes in it. You can use a Ritz cracker that has a hole in it. The other thing is you might even see the eclipse image filtering through the space between leaves on our tree. There's some really wonderful ways of catching imagery of it. So be safe, but don't think you absolutely have to have the glasses. That is not your only option. Should we talk a little about the science of that?
We should, but before that, I just want to give a shout out to our website because you're talking about all these great ways to indirectly view it. And again, just a plug for the eclipse2017.nasa.gov site where you can find all kinds of information, but especially some do-it-yourself instructions on how to create some of those indirect viewing methods.
Great, we've talked a lot here about the partial eclipse. Nikki Vile, who you just heard talking, she studies the corona, that is the atmosphere around the sun. And she was telling me just the other day how excited she is that she is going to be able to see that with her naked eye during the actual total solar eclipse. So that's what's interesting. We can only see that normally from space with our space telescopes.
Right, and even with that, I was talking to one of the heliophysicists back at NASA headquarters in Washington, D.C. Recently about this, that even with those artificial eclipses that they create from the coronagraphs, they're called, in space, it doesn't give you the same viewing opportunities that we have with a natural eclipse like we're seeing now. That there's actually a couple different layers of the sun's corona. We have the outer corona and the inner corona, and because of the way those coronagraphs work, they do not allow a good image of the inner corona, the part that's really close to the sun's surface. Only the outer corona. It's only during an actual natural total solar eclipse like we're viewing today across the country that scientists, heliophysicists, and others, and just the general public are able to see the entire corona, and that really gives them a lot more information. And remember, for these scientists, no matter where they are, they only have that brief, maybe 2 minutes, maybe 3 if you're really lucky, right in the center line of totality, to see the entire corona and get those measurements.
Yeah.
So again, Karen, folks are looking at their screen right now. You see that double image, Salem, Oregon, there on the left, and nearby Madras on the right. Two different images with two different types of telescopes using to view this eclipse. Still in the partial stages, starting to get closer and closer toward totality in just a few minutes.
And stick with us because we are going to be tracing this eclipse all the way across the country. Not only does everybody in the country have a great view, but we have some views from the sky, don't we, Sean?
That's right. Looking up from the ground is how most of us will experience today's eclipse, but researchers at Southern Illinois University wanted a different perspective. They wanted to look down at Earth to image the moon's shadow. In Illinois and across the United States, teams are using high-altitude balloons for a unique perspective.
Right now, they're getting ready to launch a research balloon from Saluki Stadium in Carbondale, Illinois. We're going to go back to Carbondale, Illinois. The primary payload will be a real real-time, high-definition video system. So let's check in on the progress of that launch.
Let's take astronomy here. Let's take astronomy here. Let's experience it in 4D.
Eclipse in 4D. It's just like being on the surface.
But you know, to actually understand the corona is very important because all sunlight stars have their corona. We need to understand why the energy is released.
All right, look, we're getting a call. All right, look, we're getting a call. We need to go inside the stadium right now. They're about to launch the balloon for the Louisiana Space Grant Consortium. So let's go to Kevin, who's standing by.
That is what's going to let that get safely down to the ground.
And all those instruments. And all those instruments.
Strung out along there.
Okay, can you hear me okay? Okay, can you hear me okay? Right. Yes. This is Kevin Boucher. This is Kevin Boucher. Sorry about the little mix-up. I was too enthralled looking at this fantastic weather balloon that has just launched. You can probably see it behind me. It is pandemonium here, but it's good pandemonium. One of the weather balloons has launched, and with me is one of the team members. Introduce yourself to the entire world. No pressure.
Hi, my name is Colleen Fava. I'm the program manager for the Louisiana Space Grant Consortium based at LSU.
So just to kind of keep a scorecard for people if they're wondering, we talked to, I guess, the program director, Dr. Gregory Guzik. He is your boss. What exactly does your job entail with this consortium?
I manage the program, so I write grants and reports and organize students and keep them on track, and I do communications training.
Sounds like you do a lot of outreach as well, and it thrills my heart, and I'm sure it thrills your heart to see so many of these young people. You probably did not have to drag these young people kicking and screaming to do this help, did you?
We brought four institutions with us, and LSU is the home team, and so they were always coming, but we actually had a competition to figure out which other students we'd bring, and we brought a team of 46 people.
And right behind you now, I had forgotten they're launching two balloons. Now the first balloon, I think we have a video of the first balloon. Okay, we're getting ready to launch the second balloon. Okay. The first balloon, Colleen, that was launched. Where is it right now? Maybe 2,000 feet, you think?
They go up about 1,000 feet a minute, so a few thousand's probably been a couple of minutes now. So.
There it goes. This other one has launched. It's a big yellow balloon filled with helium. And the next time we see this balloon, we'll be down on the ground. It'll have wonderful data. Can you tell us about what goes into studying the winds and the weather reports, trying to calculate where this will land so you can quickly retrieve it and get your data? That's a whole other science.
I'm not an expert on it. I can just tell you that we do our predicts. We started our predicts months ago, doing them, maybe every week or so, and then the last few weeks we've been doing predicts every single day. So we have a good idea. We think it'll go about 36 kilometers, about 22 miles, somewhere near Marion. So we'll have several chase vehicles kind of staged and ready to go. And I'm not sure if they decided to leave before or after totality, but we have some local people helping us to make sure we have access. And we're hoping, expecting to be a pretty easy recovery.
Will you actually be on the chase team yourself?
No, I'm not going to be on the chase team. I need to do logistics here on the ground. I have been on a chase, though, and it's very exciting.
I'm sure. Can you tell me about it? And please get as specific as you can. What are some of the most eventful ones? Like, has the balloon ever come down in
Pontchartrain River?
How did you know? You're not kidding me. You're not kidding me.
I'm not kidding. We did have a landing in the Pontchartrain River, which was not a great recovery, but it was definitely better than landing in the airport, which we were afraid was going to happen.
I was going to say I would rather land in an airport because the Pontchartrain River, you have the water that might damage some of your instruments, but you're the expert then, right?
I think we'd rather not interfere with air traffic control.
Landing in a Pontchartrain River, and I assume the alligators did not make a meal out of your several $1,000s worth of instruments?
We didn't recover that payload, but we have done water recoveries in the past, and we actually just invested in an inflatable kayak.
My producer just told me we are seeing first contact. Everybody, we have people putting on their glasses the first contact. We are seeing the first contact. And we've got about 4 minutes left. How many total solar eclipses have you seen, Colleen?
This is my first.
I assume you have your glasses. I assume you have your glasses. Feel free to go ahead and put your glasses on. Yes, please. If you don't mind, I'm gonna.
You can project little images of the eclipses down onto your route. So make sure you look down just as much as you look up.
Right. Okay. My glasses are on. Are your glasses on too? Okay. Okay. And the sun we are turning around. Would it be okay if I turn my back to the camera so I can see the sun? Okay. I'm going to turn my back to the camera. I'm going to turn my back to the camera. Oh my gosh. There is a small bite starting in the sun. What are your comments? What are your comments?
That is gorgeous, isn't it?
That is fantastic. That is fantastic. The total solar eclipse in Carbondale, Illinois has begun. A small bite is being taken out of the sun by our satellite called the moon. This is incredible. This is incredible. Earlier they were telling people to talk about in one word to describe the eclipse. The word for me is majestic. A lot of times, I don't know about you, sometimes if I want to, take a break on my computer, I can take these out. I will go to the solar, I think it's the Dynamic Observatory that often will give videos of the rotating sun. And Colleen, I don't know about you, but when I see that giant ball of gas just rotating, majestic is a word that comes to my mind. Could you agree?
I absolutely agree. It's amazing. And I think that we're really fortunate to have this opportunity and to be in community with our students and faculty and staff from multiple institutions here at SIU who's been wonderful and very welcoming. It's just extraordinary.
Thank you very much for your time. Keep up the great work. Thank you for talking with us. That was Colleen Fava with the LSU.
Thank you so much to Carbondale.
Thank you, Carbondale. That was amazing.
It's great, and I love looking at those images and how you can see different things at different parts of the country. It's wonderful to be sharing this imagery with all of you. We will have more from Carbondale later today. Please stick with us. We have so much coming up.
From there and from here at NASA's Eclipse Central here at the College of Charleston.
Looking out toward the horizon, we await the first glimpse of a total solar eclipse when the movement of our moon completely blocks our view of the sun. Starting in the air from NASA's Gulfstream 3 aircraft off the coast of Oregon, we anticipate this awe-inspiring celestial event. Over the next 3 hours, we will track the solar eclipse as it moves across the entire United States from coast to coast, observing this incredible event through the eyes of NASA. Hello and welcome. I'm Dwayne Brown from NASA's Office of Communications. And over the next 3 hours, we're going to look through the eyes of NASA and experience today's total solar eclipse. I have a great team here on stage. Joining me to my immediate left is Jadi Collado Vega, who is a space weather scientist. Solar scientist next to her, Alex Young. Over to my right, John Yerbick, who will be taking your social media questions today, plus media specialist and meteorologist, very important man today, I must say, tracking the weather conditions across the path of totality. Sean Potter. Today we're coming to you from NASA Eclipse Central here at the College of Charleston. Now, Charleston is the last stop of the total solar eclipse on U.S. soil. So we will track this eclipse as it moves east and heads this way. We're tracking the eclipse across the entire country to bring you the best images with the most compelling stories, along with science experts. Here from NASA Eclipse Central, we have views from ground telescopes, high-altitude balloons, airplanes, and from several NASA spacecraft. And I want you to remember this audience out there. We even have live, no one else, only here at NASA, the International Space Station. If you want to see the eclipse as never before, stay with us through the eyes of NASA on NASA television. This is the place to be. Daddy. Hola, ¿cómo estás?
Bien, ¿usted?
Okay. This is a win-win situation for America. We have a partial eclipse and a total eclipse. Explain the difference.
So today, pretty much, the moon is going to come across the Earth and the Sun. North America, Central America, and parts of South America are going to see a partial solar eclipse, which means that the moon is going to partially block the sun. It's going to look like the moon took a bite of the sun, like you have seen on the previous images. A total solar eclipse is going to happen in a very narrow path, 70 miles wide, that comes all the way from Oregon, crossing the whole continent of the United States, and getting out here in South Carolina, you're going to see a total solar eclipse, which means that the moon is going to completely block the surface of the sun, and you're going to be able to see the solar atmosphere, the solar corona, with your own eyes. They will turn into night, which means the stars and the brightest planets are going to come out.
Jody, Alex, you guys have been waiting for this for a long time, as all these other scientists around the nation. This is the day we've been waiting for, and we're here. Eclipse Central. You guys, if you're here, this is the place to be. We have remote NASA TV broadcast sites along the path of totality, so that anyone watching along with us can also experience the total solar eclipse. We'll also share information about how to experience the eclipse safely, wherever you are, and give you a peek at all the exciting plans NASA experts have today. Alex, Mr. Solar Man, what is so unique about the solar eclipse?
Well, this is an amazing opportunity. The last time we had a total solar eclipse in the continental U.S. was '79. But the last time we had one that went from coast to coast was 1918, 99 years ago. So we are having a total solar eclipse that's covering a huge portion of populated, accessible land. This is giving us an unprecedented opportunity to study, to look at the impact on the Earth, to see the corona, and give us science like we've never had before. And the last time we had this kind of connection to where we are and who we are was actually really the Apollo 8 Earthrise. And that gave us a perspective outside of just the Earth. showed us that we were part of something bigger. And that's what this total solar eclipse brings for us. It allows us a window into the universe. And this is the most connected, most well-observed event that we've ever had in terms of a total solar eclipse. The data and the experiences are going to be amazing.
Okay, so we're certainly witnessing a monumental celestial and historical event today. We'd like to take a moment to talk about safety. So, Jody, can you help me out here? So, never look directly at the sun. And you may have seen these eclipse glasses. They're designed with special purpose solar filters. Ordinary sunglasses, even very dark ones, are not safe for looking at the sun. Now, if you're in the path of totality, there is a short time frame that you can take your glasses off. This is only when the moon completely blocks the sun, and that is during totality. Let's watch this video to learn more. Okay, so Alex and Jody, I'm very fortunate that I have glasses. A lot of people have glasses, but a lot of people don't have glasses. So what are other options? Let me start with you, Alex, on how they can view the eclipse.
Well, the simplest thing to remember to look at it indirectly is a pinhole viewer. And there's a lot of ways you can make a pinhole. You can take a simple piece of paper, poke a hole in it. In fact, I've got here a 3D map of the path across the U.S. with a hole in it that I can use as a pinhole to project the circular sun down on the ground, and then you can see the moon move across it. As a matter of fact, anything with holes, including this colander, is something you can use to look at the eclipse. But you can also use something a little more sophisticated if you want.
You can actually make a box. You actually do two holes in one side of the box, and then put white paper on the inside. Then put aluminum foil, do a hole in the middle, not too big, that you can actually project the sun inside the box. Make sure that the sun is actually behind you, so you can actually look at it inside of the box. It will be an amazing projector.
Okay, so before I toss the social, I got to do this because we're on the College of Charleston. And College of Charleston students, make some noise! That's what I'm talking about. Okay, so the social media world is going to break records. So let me toss to my man John on the social front. What's going on?
There are literally millions of people watching this broadcast right now. We're going to be monitoring the conversation online and taking your questions as a total solar eclipse treks across the United States. There's a tremendous amount of excitement online, and we want to share with you at home. So we will show you images of the eclipse from your unique vantage point. Submit your pictures and questions using the hashtag Eclipse 2017 and follow the conversation online. For updates, be sure to follow. Let's see if I can remember all these. NASA on Facebook, Twitter, Instagram, Snapchat, and LinkedIn. Additionally, we're providing live coverage during the eclipse on Facebook Live, on NASA's Facebook page. You can ask your questions in the comment thread. Check out their streaming sites like NASA's Periscope account on Twitter, Twitch TV, Ustream, and on YouTube. And of course, you can watch it on NASA.gov and NASA.gov/Eclipse Live and on the NASA app. And we have a special feature for you. We have a special feature for you. If you visit our Facebook Live page, along with this broadcast, we have a 360 view from right here in Charleston, South Carolina. With this tool, you can pan around on your computer and mobile device. Look up to the sky as the moon transits the sun during the eclipse. It'll be like you're right here with us in Charleston, minus the sweltering heat. Visit the NASA Facebook page and check it out. Finally, share your image of the eclipse with us using the hashtag Eclipse 2017 on our Flickr page, which is up here online right now. Share your images with us, and we'll share them right here in the broadcast and also on social media. And finally, enjoy your eclipse viewing, and remember to ask your questions with the hashtag Eclipse 2017. Back to you, Dwayne.
Social media is going to break some records, and we're going to be coming back to you more and more. So you got to know that one of the most important things here for today is the weather. So Sean, I'm looking at Charleston skies. We got clouds. I hope that's going to get better. But what's going on around the nation? Over to you.
That's right, Dwayne. Yes, the weather is the key factor for viewing today's total solar eclipse. Right here in Charleston, it's about 86 degrees, but with the humidity, it feels more like 99 right now. But what we want to do right now is show you a satellite image from our friends at NOAA, the National Oceanic and Atmospheric Administration. This is from the GO-16 satellite. It's a brand new weather satellite that NASA built for NOAA and was launched last year. That's going to give you the latest and greatest, very detailed imagery of cloud cover across the country. And what you can see is that things are looking really good for the early parts of the path of totality, places like Oregon and Idaho and Wyoming. And then as you get into parts of the middle section of the country, more places like Beatrice, Nebraska, maybe into Kansas City, Jefferson City. There is some cloud cover there that may hinder your ability to view the eclipse. And looks like as you get into Carbondale, skies are still pretty good there. There are some storm systems developing to the north in other parts of Illinois. And really, things are looking clear again until you get back here in Charleston. As you said, Dwayne, I'm looking up at the clouds to where the sun will be in about an hour. And there is significant cloud cover, but we're keeping our fingers crossed. I do see some pockets of blue in there, so hopefully we'll get to see something, but we'll have more for you later in the broadcast, Dwayne.
Hopefully you can use some of your connections to get us some good weather here in Charleston. So the moon is already moving across the face of the sun. We're getting close to viewing our first total eclipse of the day. We're minutes away, and remember, the total solar eclipse starts on the west coast of the United States in Oregon, and we will be bringing you live images as it occurs. NASA's Ames Research Center's Jesse Carpenter is standing by in Salem, Oregon at the Oregon State Fairgrounds. Jesse, give us a status report.
Oh, wow. Thanks, Dwayne. Totality is almost here. This is so exciting. Oh, this is so exciting. And just before we get to that, though, I want to introduce Andrea Edgecombe again from the Oregon Museum of Science and Industry. Hey. Tell us a little bit about this really fun, cool viewing event that's going on here.
We are here. We have almost 9,000 people here at the Oregon State Fairgrounds, and we've had some cool stage presentations. We heard from NASA astronaut Don Pettit. He's an Oregonian. We had a University of Oregon professor, and behind us we have some space science partners who've been doing some cool educational activities and really interacting with the crowd. So it's been an awesome morning, and we can't wait for totality in a few minutes.
This is such a great event. Thank you for joining us again. We really appreciate it. I know you got to get going.
Yeah, thank you.
It's coming soon.
Joining us now to talk to us about the sun and give us more information is NASA lead scientist for Eclipse 2017, Madhulika Guhathakurta from Ames Research Center.
Hi, Lika. Hi, Lika.
It's almost here.
Hey, it's almost here. It's almost here. How many eclipses have you seen?
I went to see 9 eclipses, and I actually landed up seeing 6. The other 3 had inclement weather. We don't have that here today.
We don't have that here today. No, we don't, and it's going to be 7.
What can you tell us about the sun that'll help our audience understand better?
I just want to start by saying I'm in awe at this moment right now, and whatever I say, kind of take it with that filter, because we are very close to totality.
We are.
We live in the outer atmosphere of this magnificent, dynamic, magnetically variable star that dominates every cubic inch of space in our solar system. And if I can get the video, what you would see in the video is that the sun produces storms that can be all engulfing, generating this environment called space weather. The inner edge of the corona that you see that's black in the video is because the sun is so intense that it overwhelms the dim brightness of the corona. And so even from space, we can't absorb the inner part of the corona. And not only Earth, but the entire solar system, as you can see, lives with this dynamic star. Corona is the region where space weather is born, and conditions are set for a supersonic solar wind and a super hot corona. Two of our outstanding questions in heliophysics in physics, really. To understand the corona better, NASA is actually going to be launching a mission next year, almost a year from now. How coincidental. Called Parker Solar Probe. It is actually going to go touch the sun, and it's going to get closer to any other spacecraft has gone before, to the sun, to study the corona, to actually sample the very corona that we will be seeing very soon.
Yes, we will. It's almost here. Thank you, Lika, for joining us, and thank you for sharing that. So now we're going to take it back to NASA Eclipse Central in Charleston. Take it away, Dwayne.
Okay, now just now coming in, we have an exclusive of the total solar eclipse, and it is arriving at the United States. It's over the Pacific Ocean and about to reach Oregon. This is the celestial event that we've all been waiting and anticipating for years. We'll begin looking through the eyes of NASA out the window of our G3 aircraft. Let's take in the view. And now we're looking at the first glimpse of the total eclipse from the ground. Wait, let's see. That's still the G3. There we go. And now we're looking at the first glimpse of the total eclipse from the ground on United States soil. This is coming to us from Salem, Oregon, where thousands of people are gathered and experiencing this monumental event, a total solar eclipse. Let's take a look and take in the view. That's the G3 there. Is that the real thing? Is that the real? We're going to keep that up, and then we're going to do reactions. Okay, so
As the moon has now moved, the sun is appearing again, and we can see the diamond ring. It's amazing. It's fantastic. You see the outer edge. You see the outer edge. I see prominences, little red pieces of chromosphere from the lower atmosphere. This is amazing. This is absolutely amazing.
What we got? Jody, what we got?
That
looks pretty cool.
I mean, it's breathtaking. Even seeing it right now through the TV, it's just an amazing thing to see. I cannot imagine what we're going to feel here in South Carolina when we have our chance.
Well, I hope we have our chance. Sean, get that weather up here looking good here in Charleston. Now, what do we, Alex, what are we seeing here?
Is that from the G3? That looks like from the G3 because I see spectra there.
No, still from Salem.
That's still from Salem. Okay, so you're seeing the bright, actually the camera is causing a little prism effect there, and you're seeing the bright light from the edge of the sun. So that is really beautiful. That's sort of the edge of the diamond ring effect.
So now, a reminder, Alex, when that diamond ring pops up, that's when people should put
That's when people should put your glasses back on. So when you see that diamond ring after totality, that's the signal to you that it's time to put it back on. So look now, we see the corona in Madras. That's gorgeous.
That's amazing. Being able to look at that with your own eyes is an amazing experience. And that only can be seen when you have this kind of totality.
The corona, that's the
solar atmosphere.
That's what solar scientists really live for, right?
Right. That is the origin. That is where the origin of space weather comes from. That's where it comes from.
That's where most of the solar flares, the corona mass ejections, big explosions of particles originate from.
There was solar activity. There was solar activity. We see it right now. Would we be able to see that popping up on the sun?
If there was a coronal mass ejection leaving the sun, we could see it there because, in fact, we have seen it in the past, and I'll even show some history later with images that people drew of these coronal mass ejections leaving the sun during a total solar eclipse.
Why is it so critical and so important to really get this type of view from the sun's atmosphere from the corona?
You mean like in a total solar eclipse? You mean like in a total solar eclipse?
Oh, there's the diamond.
That's the diamond ring again. That's amazing. That's from Madras. It is important to do this because we do this kind of eclipses artificially, but we do not do it as perfect as nature does. The moon covers the sun in such a perfect way that we see parts of the corona that we don't usually see.
So Alex explained that. Safety too, right?
Safety too, right? So right now, this was the moment when you see that flash of light. That's the moment when it's time to put your glasses back on or start using your indirect methods because now it's too bright and it could damage your eyes.
Safety first, people. Safety first, people.
Always. Wow. So the folks in Salem, Oregon, I mean, they're like juiced. I mean, they got it. Juiced. I mean, they got it. They got the good.
They've got a perfect view, and they are seeing one of nature's most amazing spectacles.
I can just only imagine the reaction on the ground from the folks there.
Oh, they are probably completely overwhelmed right now. Completely overwhelmed.
Well, I certainly hope we get something like that. We've got it here on NASA television through the eyes of NASA. We got the International Space Station coming up and other images only we can bring.
Only NASA can bring, yes.
Now is it completely dark or is it coming out?
No, what's happening now is the filters are back on, the safe solar filters for the telescope, and now you see the crescent, which is the sun basically now being revealed after the eclipse. So we're now back to the partial phase in the other direction.
Now how fast is this going?
Well, this shadow is passing across the country, depending on where you are, anywhere from 1,200 to 1,800 miles an hour. So this is moving incredibly fast because the moon itself, in its orbit, is moving at almost 3,400 miles an hour. And that, in combination with the rotation of the Earth, is what gives us a shadow moving that fast.
Okay, so Gotti, let's talk about space weather. Seeing this in space weather is so important. So just let us really understand why it's important in space weather.
Space weather is So space weather is pretty much the conditions created outside in space due to the sun. We look at space weather because we want to understand these conditions. If you look at the image that you have now, you're going to see SDO image, the Solar Dynamic Observatory. That's where we actually look for the source of space weather, where the solar flares and the coronal mass ejections actually originate from.
Well, when we look at
SDO, at the images,
we also have to look
at artificial eclipses.
Like the one that you're looking at online
Like the one that you're looking at online now.
These are actually from the SOHO
spacecraft. These are the artificial eclipses that I was talking about, Dwayne.
You have to block the solar surface
to be able to see the solar atmosphere, the outside corona.
You're going to see something like this today.
And you saw it. But you're going to see it better because nature does it better than we can actually do it artificially.
Right now, the activity is not,
there's not too much going on in the sun. However, if I do a historic event, which actually was from this past July, you can see a coronal mass ejection, this big explosion of particles that come from the sun.
Well, those look pretty intense. Do we have to worry about that? That doesn't look good.
Well, space weather, what can actually do is affect communications. We have the magnetic field of the Earth to actually protect us. It's our shield. And what we do is we actually can analyze that using real-time models like the one that you see on the screen, that we actually understand how the magnetic field of the Earth changes with those coronal mass ejections. But space weather can affect communications, satellite instruments, and power grids.
Okay, so we're going to toss to Idaho. And I think we've really got some good stuff here. Gay Hill, are you there in Idaho Falls?
Absolutely here, Dwayne Brown. In fact, looking through the glasses right now, it's so weird. We have a crescent sun instead of a crescent moon. This is the. I think we haven't had a total eclipse here in Idaho Falls since 1889, 128 years ago, and things have certainly changed in Idaho Falls since then. There's a whole lot more people, especially with all the visitors in town. We're just outside the Museum of Idaho, and we have partnered with the museum to make this an official viewing site for Idaho. And they right now have an exhibit on space, but we also sent in a team of experts. And for the past 3 days, we've had talks, we've had demonstrations, we've shown them visualizations such as eyes on the solar system, and we've shown them artwork. But really, the order of the day is the eclipse, and NASA has that covered too. They have sent an army of volunteers. We call them solar system ambassadors. They are all along the path of totality, and they're volunteers. These are people just telling people what they're seeing and helping them understand. We have one here, right here. His name is Richard Stepper. Hey, Richard. He has been manning in this mobile observatory, and that is what is providing our solar telescope shot right now. Now, we asked him, what's it like being a solar system ambassador? And he said, follow along. We did, and we went with him to a place, a school in Southern California. Take a look. We apologize. There is no audio on that video, but it talks about the solar system ambassadors. There are about 720 in the United States. They get special training from NASA. They learn all about the missions and about the science, and they basically go out to public events all over the country teaching them about NASA missions. If you would be interested in becoming a solar system ambassador yourself, you can. We have a website. Look it up. Solar System Ambassadors. It is a NASA website. And starting September 1 through the end of the month, you can sign up to be a Solar System Ambassador. So check it out on the web, Solar System Ambassador. With me now is Jim Green. Jim Green is the head of planetary science for NASA. He's in charge of all planetary missions and asteroids. This guy knows his stuff. Let's talk about this. Now, you see this eclipse that doesn't happen. It happens once in a lifetime. But as a scientist, you see it as an opportunity.
Oh, absolutely. I mean, we're getting the eerie feeling right now, but when we launch balloons, and there'll be 57 balloons along the path, 30 of which are going to have a planetary experiment on them.
And we have video of this. Now, just a few days ago, we had a crew here. They did a test launch for us, and they sent up an imaginary payload for us just to see how it all works. You have actual scientific experiments going up.
We do. We have bacillus. It's a harmless bacteria. We have on 30 balloons 2 coupons where the bacteria will be sprayed. One will stay on the ground. One will be affixed to the balloon. It then will go up to 100,000 feet above the ozone. So the ultraviolet light, also blocked a little bit by the moon, is just like Mars. In addition to that, the temperature and pressure will be just like Mars. So when the balloon goes up higher and bursts, comes down, we'll retrieve that coupon off the balloon, match it with the one on the ground, and then we'll see how many survive.
Now, why is that information so critical for Mars research?
This bacteria is pretty much everywhere. It's very hardy, and it probably has made its way to Mars, perhaps even on our rovers. And I would like to know if that environment is so harsh that it would eliminate that bacteria or not.
I'm being selfish. I'm being selfish. I have never seen a total eclipse. And I'm sorry, I would love to talk to all of you people, but I want to put on my glasses too and take a look. Can we continue this conversation? All right, and watch, and we can talk. All right, so we still just a little sliver of the sun right now. And let's talk about this. Why is this so rare?
Well, you know, the plane of the moon relative to the Earth's sunline is tilted by 5 degrees, and so there's only 2 places where the moon and the Earth and Sun are on that same line, and that's why every 18 months or so we get an eclipse. 1 minute away. Wow.
The crowd is getting excited.
It's already so eerie.
Wow, it just got dark all around us. And you can feel the temperature getting colder.
The winds are really picking up. You know, in this dark area, the winds are just flowing in.
Oh, you can just it's just a tiny sliver right now. Closing up.
There it goes. It's going. Getting smaller. Look at the ray structure. You can't get that on film. You can't get that on film. There's Venus. There's Venus. Wow. Oh, look at that ray structure. Oh, look at that ray structure.
You were saying this is the only way you can see the atmosphere.
That lower part of the corona is really even hard from space to see. Wow. I got to spend a second looking around at the crowd. Oh my goodness. Yeah. Wow.
We should turn off the lights.
All right. Did you get ready? Just put it back on there, son.
Okay.
Pretty quick.
Have you noticed, Jim? Have you noticed, Jim? The street lights are all on around.
The street lights turned on.
We confuse the street lights.
Of course. Who would have thought? Who would have thought? We didn't plan that one.
All right, we should get ready for our glasses again. Get ready with your glasses. Get ready with your glasses.
Okay. There it goes. There's the diamond ring. There's the diamond ring.
Oh my gosh. Oh my gosh.
Yeah. Wow.
That is
Was
so.
that all right?
Oh my gosh. Whoa. Oh, that's brilliant. Oh, that's brilliant.
All right. Wow.
Okay, glasses back on. Okay, glasses back on.
Too brief.
Okay. We're gonna have to wrap this up pretty soon, Jim. That was incredible.
Way too brief.
We got a minute 50 seconds. That was all we had. Why is it that some parts of the country get a little more than we do?
What has to do with the curvature of the Earth also? And so the shadow is at various altitudes. You could go up at a higher altitude and get also a great view too.
Well, this was a real treat. This was fantastic. So Idaho Falls has had its total eclipse. The next one is coming in 2252. We won't be here, but we hope NASA will. Back to you.
Gay Hill, that's Gay Hill from NASA's Jet Propulsion Laboratory. Gay, I'm jealous. I'm telling you, I'm jealous. So Alex, explain again that diamond.
The last bit of sunlight, when you see it at the very beginning, is when the last bit of the sun, the crescent, shrinks down to a little tiny bit. At the same time, you can see a ring of the corona around it, so that makes the ring, and then that bright bit of crescent gives you the diamond. So when it reappears, you get the same thing. The last bit of corona is a ring, the flash of the sun is the diamond giving you the diamond ring. It's a beautiful, beautiful sight.
And real quick, and then I'm going to ask you a question, because there was something going on here in Charleston. The planetary. Jim Green said something about Venus. This is really cool for planetary science because you can see other planets, right?
Absolutely, and as a matter of fact, one of our missions through the WB-57 aircraft are studying Mercury, which is very, very close to the sun.
So we're gonna come back to you, and we're gonna talk about what's happening here. So next up, NASA's ready to take a bite out of the Big Apple, one of my favorite cities, Jotty, New York City. Today's broadcast is being shown, I believe, in Times Square on the Toshiba Vision screen, so the city can also enjoy the spectacular views of today's total eclipse. And we've got a great relationship with Toshiba, so a shout out to you guys. This Midtown Manhattan tourist location is always bustling with crowds. On the average day, over 300,000 people pass through Times Square. Alex, I'm gonna turn to you. You know, New York, they're gonna get a partial, but they have a rich history in solar eclipse.
They really do. So actually, 92 years ago, on a cold January morning, New York City, Manhattan, and Queens experienced a total solar eclipse. The edge of the path of totality went from 95th Street to 97th Street. This was an amazing opportunity. This was the first time we sent up two dirigibles with the U.S. Naval Service for scientists to study this. At the time, we actually thought eclipses could be creating radio waves which mess with communication. But what in fact is happening is the sun itself is creating this disturbance. So studying the eclipse is actually telling us about the sun, which is creating these disturbances here on Earth.
Okay, so this just in. I believe we have results from an experiment that occurred on NASA's Gulfstream 3 aircraft from NASA's Armstrong Flight Research Center. Karen Rohr is standing by with Thomas Zabuka, the Associate Administrator for the NASA Science Mission Director. Let's go now to see what the instrument observed during the total solar eclipse. Kevin.
back here at the G3 up over the Pacific Ocean off the coast of Oregon, and it was amazing, wasn't it? For me, at 25 years I did research on the corona. I saw it for the first time. It was my first eclipse. Was it your first eclipse?
My first eclipse as well.
Just absolutely amazing. And I want to talk about two things. First of all, the shape of the corona. I saw the models. I showed the model, and it was remarkably similar. I saw these streamers, these magnetic structures coming out like glows in specific directions, just like we expected. So I'll look for the analysis before we claim victory, of course. But the other one is that spectrograph you, Mike, ran on board. And just before that the sun, disappeared behind the moon, that spectrograph, of course, is spreading out the light in all its colors. Just before it disappeared, there is that one shot that Lori, I'm going to ask you to turn it on. Do you see those specific kind of lines that pop up? Between the green and the red, it's just like we said, it's helium. Remember, that's how it was discovered, helium. We didn't know we had helium here. It was a new element. It was discovered that way. And then over there in the red, the red is iron. Iron, a really hot iron, telling us that, hey, this atmosphere is really hot. And then it's another line, red. It's another line, red. Well, what is that? Hydrogen. Well, hydrogen. Well, so even though it's really hot up there and only 1 in a million or 10 of million particles are neutral, it's still visible in that one shot that you saw. So, Robert, back to you here, back on Earth. What did you feel like? How did you see this occur?
It was fascinating to watch actually the shadow or the path of totality underneath us. We're at 35,000 feet, and you could see at totality, you could actually see the darkness down on the ground. And you could look north and south and see where it wasn't completely dark. As we kept going, you could just watch that darkness move. It was almost like a thunderstorm moving across the plains. But it was all the darkness. It was just stunning to me to see that.
Really good stuff.
Really good stuff. And I wasn't expecting that. And of course, the eclipse itself was beautiful, but seeing what happened down on the ground level of Earth from 35,000 feet was amazing. I just got to tell you, the team on this plane and the team all the way around this country is doing a fantastic job. I wish you could have seen the folks here working to make sure we got the data that Thomas showed. Some fantastic images we've already looked at that I can't wait to share. With everybody and for everybody to see. But really exciting to watch this team work, and the pilots did a great job. We had a little bit of a challenge right at the time of when we needed to be best, but they did a great job recovering from that, and then kept us on path all the way through.
So thank you guys.
Anyway, so thank you guys. Remember to put your glasses on for those who hadn't seen it yet, and we'll talk to you soon.
Fantastic stuff. Fantastic stuff. And if you just tuned in here, you're watching Through the Eyes of NASA television. We have the best views of the solar eclipse today and coming later in the show. You don't want to miss this. The International Space Station live. Now, next up, let's visit a working farm at Austin Peay State University in Clarksville, Tennessee. Agricultural observations and solar eclipse viewing activities are underway, including high-altitude balloon launches and painting cows.
Painting cows?
Okay.
What?
All right. Okay. All right. Let's go to the NASA Launch and Space Flight Center. Chris Blair standing by.
People are naturally excited about the solar eclipse, but one thing we've learned on this working agricultural farm is that animals can as well. But more on that in a moment, as right now we're getting ready to do a live scientific balloon launch. And joining us to tell us more is Dominic Critchlow from Austin Peay State University. Thanks for joining us. We appreciate it. So tell the crowd and our audience a little bit about the scientific payload you have on board.
Thank you for having me. Today we're flying some still image equipment, and we're going to be taking images of the ground in different wavelengths. And we're also flying live streaming equipment, so we can live stream the eclipse, looking downwards and looking around, and at 100,000 feet, which is higher than any plane has ever gone. We're also flying some biological samples with NASA Ames, and then some our trackers, so we can have a successful recovery.
Okay, they just released your balloon, so let's talk about the NASA science and the biological samples. Explain more.
So NASA Ames has contacted us and all of the other teams that are going to be doing launches today across the whole path of the eclipse. We're going to be all have a little chip of biological samples on today. Across the whole path of the eclipse, we're going to be all have a little chip of biological samples on there that are going to go up in the stratosphere, which is a similar atmosphere as we would see on the Martian surface. So we're doing some Martian studies, which is really interesting and cool.
We are very excited about that. And so, also, how many balloon releases are you planning on doing this today or this weekend?
And so all across the U.S., we have about 50 teams that are launching in the path of the eclipse so that we can have full coverage of the stream. And on the site today, we have 3 launches from 3 different universities. And we're just really excited to be here and hopefully all successful launches.
All right, so finally, these balloons do go up and they come back down. And so what's some advice if anyone finds one of these payloads out and about across the country? What's a tip you would tell them?
If you find it, leave it there. Maybe take a picture because it's kind of cool to see something land in your backyard from research. And please don't touch it. We'll be there soon to pick it up. If you have to move it, let us know, and we'll just be there to recover it.
Awesome. Thanks. We appreciate your time. Appreciate it. Okay, so yesterday we had a chance to catch up with some serious students, albeit a little younger, but serious about doing real-world science nonetheless. And here to tell us more is my good friend and colleague, Mitzi Adams from NASA's Marshall Space Flight Center in Huntsville, Alabama. Mitzi, thanks for joining us. We appreciate it. So tell us about the science that these high school students are working on.
The students are actually working on some atmospheric science experiments. They're doing animal study experiments, and they're helping us observe the sun in various wavelengths of light.
And these students aren't just from the Clarksville area. I understand they're all around the country, if not perhaps the globe.
The students are from the U.S. Space and Rocket Center, and yes, they are from all around the globe. And they're actually from the Inspire project as well. They're participating in VLF radio noise experiments, and those folks are from Washington, D.C.
Excellent. So you mentioned the Space and Rocket Center, Space Camp. That's the official visitor center for NASA's Marshall Space Flight Center. Feel free if you're in northern Alabama to come and see us. They do a great job of representing a past, future, and present history of NASA. So any parting words?
In the words of Frank Reynolds, I'd like for us to remember for the next American eclipse in 2024, let the shadow of the moon fall on an earth at peace.
Very poetically done. We appreciate it. All right, so up next is, as promised, our Animal Lovers segment. And so here on the agricultural farm, students are studying a really cool STEM field. So it's conservation management, it's veterinary medicine, animal biology, and so they're interested in animal behavior. And so joining us is Dr. Donald Sudbrink, head of the Ag Department here at Austin Peay State University. And so it's not cow tipping, it's cow painting, correct?
Yes, we had to paint the cows that are in this study to see what sort of things that they would do so we could record the individual animals so we could see what behaviors that they were exhibiting.
So we saw the cows, and the students were involved with that Mitzi just spoke about. We're also talking about cricket behavior and cricket observations.
Yes. Yeah. Well, we're also talking about crickets. I'm an entomologist by training, and crickets generally chirp at night. So we're going to get a chance to see a series of isolated males and see what they do when the sun goes out.
Okay, excellent. Glad you all are doing this kind of observational research. Really appreciate your time. Thanks a lot. So, and speaking of time, it's almost time for us, everyone here at Austin Peay State University, to actually watch the solar eclipse. So let's go back live for continuing coverage of NASA's eclipse across America from Charleston.
Okay, so I wonder if the milk tastes better. When you paint the cows.
I don't think so.
All right,
I don't think
let's
so.
go to social media. Let's go to social media. We've been in the show here, and I know it's a buzz. So over to John Yerbrick for social media update.
Yeah, last time I looked, Dwayne, there were 2.1 million people looking online on our website, on our 1.2 on our live stream. So it's a huge conversation. And Solar Eclipse 2017 is still trending #1 on Twitter. So it's been huge. Can we go to the first slide here that I've got up? This right here is an amazing photo. Sometimes they say you have to be at the right place at the right time. This is taken by one of our NASA photographers, Bill Ingalls, out in Washington. And he captured, it's hard to see here in this picture, he captured the International Space Station transiting the sun during the partial eclipse there in Washington. Pretty amazing. You kind of have to look closely. We'll also be putting these images up online if you want to see them. But one of those little dots there is the International Space Station traveling at 17,500 miles per hour. Here's another one from our photographer in Wyoming. Same concept, capture the space station. We knew exactly when the space station was going to be flying, what its orbit was, and when it was going to cross the sun. And look here, it's just an amazing sight. I'm really proud of our photographer for getting these shots and proactively trying to get something that no one else probably has and thinking through and getting this great image. So let's take a few questions from social media. I want to remind our viewers at home that you can ask questions to us here on the set and on social media with the hashtag Eclipse 2017. So why don't we bring it back here to the stage? First question is from Twitter. What if we wear sunglasses instead of eclipse glasses? Will we actually be able to see the eclipse? Sunglasses help. Does it give you any sort of protection?
No, that's definitely a no-no. You should not wear sunglasses, normal sunglasses. Always wear the actual sunglasses that are made for solar viewing, like the ones that I'm having here right now in my hand. And if you don't have the sunglasses, you never look directly at the sun. You look like you do an indirect projection of that eclipse. Never look at the sun without the proper safety.
So another question here comes from Deborah from Facebook. So the sun rises in the east and sets in the west, and the Earth rotates in clockwise motion. Please explain how it starts in the west and ends in the east.
Well, so the Earth is rotating from west to east, but actually the moon is moving faster, about 3,400 miles an hour, casting a shadow down on the Earth, which is rotating about 1,700 miles an hour, and that actually means that the shadow is moving from west to east across the Earth at about somewhere between 1,200 to 1,800 miles per hour, depending on where you are on the Earth.
We have another one. I think we have another one. I think we have time for another one. Tina from Facebook's asked, if I place a lens from the eclipse viewing glasses over viewfinder on my iPad, could I successfully video the eclipse, or would it fry my camera?
You can actually look with the iPad or your phone to the eclipse. The only thing is, you have to be very careful not to look at it with your own eyes without the actual safety glasses. Never look at it through any lens.
This is Vicky from Facebook. Hey, NASA, International Space Station, see the shadow of the moon crossing America from space. And they have that view and they're looking from space?
They do, and that's what we're hoping to see from them. Yes.
John, we're going to come back to you. John, we're going to come back to you. So I think we're going to go back to Sean, our meteorologist. Let's learn more about how NASA is studying the Earth and Sun relationship during this eclipse. Sean, can you tell us more about that?
Thanks, Dwayne. Thanks, Dwayne. So during the eclipse, the moon acts like a giant cloud as it passes over areas in the path of totality, casting a large shadow on Earth's surface. Now, the footage you're seeing right now shows a solar eclipse that occurred in March of 2016 over Indonesia. That experience helped us determine how best to study today's eclipse. These images were taken by NASA's EPIC instrument aboard NOAA's Deep Space Climate Observatory, or DISCOVER. It's just one of the instruments we'll be using today to study the eclipse as we monitor changes in Earth's energy balance. Scientists have made extensive atmospheric measurements during eclipses before, but this is the first opportunity to collect coordinated data from both the ground and from a spacecraft that observes the entire sunlit Earth during an eclipse. Dwayne, back to you.
Thank you, Sean. Sean. Okay, so now we have a special guest with us today, the Associate Administrator for NASA's Office of Communication, Jinray Wong. Jinray, welcome.
Thank you. So happy to be here.
Oh, it's an exciting day. I'm glad you joined the team here. And our next location you are pretty familiar with, I'm sure.
I'm very blessed that I do know something about the great state of Nebraska. I've actually lived there for the last decade. And I have friends and family who are watching there from the path of totality. I have to tell you, this is by far the biggest thing that's happened in Nebraska as of recent. It's absolutely fabulous. I have had friends from high school and college calling me up, Facebook messaging me, asking where they can get their classes, where they should be viewing from. So it's just a really exciting day for everyone who's watching along the path of totality. It's also a really exciting day for NASA. And in fact, this gives us an opportunity to look forward as well. And we have a future study that we are going to be doing for to study the sun. NASA is going to launch a new spacecraft next year, the Parker Solar Probe, and it will fly directly into the solar atmosphere. The mission will provide first of its kind data, and for more information on this future mission, let's go to Beatrice, Nebraska, where Vince Whitfield from NASA's Langley Research Center is standing by. He's at Homestead National Monument, where the National Park Service has coordinated an eclipse viewing. Vince?
just in. I think we're having Vince is going to come up shortly. Jen Ray. So we're going to go back with an image, but we will be doing Nebraska as soon as we can. So a shout out to the great state.
Thank you.
Okay, folks. Jody and Alex. This is a different view here. What are we seeing, Alex?
So we're looking at a different wavelength of visible light. It's called calcium K. So this is light that's produced by excited calcium. And this is showing us the sun as the moon is moving over it. And in fact, if you look over to the left, on the edge of the sun, you actually see sunspots. And these are regions that heliophysicists like myself and Jari are most interested in, because that's where solar explosions originate from. In fact, the magnetic fields that come up into the corona that we see during the total solar eclipse originate from those sunspots.
Actually, this sunspot had a solar flare yesterday.
And I believe this is coming from. And I believe this is coming from Carbondale. So that's now it's why is it purple? Is that what's the color?
That's actually the light and the color of the light in the filter. The color is a bluish light, and so it comes out as a purple color. But it is a type of visible light. It's one we look at quite often from both space and the ground and look in the sun.
Now I see some black thingies. Look like a little river. You see it over there near the corner on the left?
Yeah, that's the sunspot.
What's a sunspot? What's a sunspot? Just for our audience here.
Those are the regions where most of the space weather actually originates, the solar flares, the coronal mass ejections, are regions of the sun that have very complicated magnetic fields. And these are where most of the magnetic energy is actually released.
So those are regions of super intense magnetic field, 1,000 times stronger than the Earth's magnetic field, and those have lots of energy, and they drive space weather.
Okay, I think that's why we didn't get the Nebraska feed right now. Those things cause that, I think, right?
That's right.
Hopefully we get Nebraska. Okay, Sean, we're going back over to you to talk about moon shattering.
We've got some really incredible imagery for you. This again from the GO-16 weather satellite just launched last year by NASA for our friends at NOAA. And what you're seeing in the western portion of this image is actually the moon's shadow being cast over parts of the path of totality. And of course, you see the cloud cover across the U.S. as well. And as I was telling you earlier, it's actually looking pretty good for most of the western parts of the U.S. that are in the path of totality. Not so good for maybe parts of the central U.S. where we've got some thunderstorm activity developing and expected to develop later today, this afternoon, for places like Nebraska, parts of Nebraska, and Missouri, and northern Illinois, so maybe north of Carbondale, and then gets better again as you see in terms of cloud cover as we move further east toward Charleston here. But here in Charleston, we still have some breaks in the cloud. Where the sun is, it's still obscured, but we are able to actually see some of the partial eclipse here in Charleston through some of the breaks in cloud. But again, really wanted to show you guys that imagery from GO-16 satellite from NOAA showing you the moon's shadow actually being cast over parts of the western United States right now. With that, Dwayne, I'm going to hand it back over to you.
Thanks, Sean. Now, as a reminder, our broadcast is tracking the total solar eclipse as it crosses the United States. It's moving along a path of totality. That's a 70-mile wide path sweeping across the entire nation. Over 12 million people live inside the path of totality. Plus, it's estimated that close to 7 million people have traveled to cities within the path of totality. I know that today is truly a day of celebration as people gather in cities and festivals to view today's celestial event. Let's get into the cultural impact here, guys. Alex, what's your take on the cultural impact of these eclipses?
This is really such a fantastic opportunity to connect the nation and, in fact, the world with one of nature's most amazing celestial events. And this is something that we, as working at NASA, are really excited to be able to share. And in fact, we even work with some of our colleagues in other parts, like the U.S. Postal Service.
Yes, the U.S. Postal Service actually created a special stamp for this event.
So what I want to do, let's talk about the stamp. Generate Charleston, Nebraska. The sunspots are gone. So let's go to Nebraska. Vince Whitfield, are you there?
We're at the Homestead National Monument of America. This is a great location to watch the eclipse. We've staked out a good spot here on the prairie. Even though the weather isn't cooperating, this is still an excellent event. We're also very prepared. Please make sure to use your protective glasses when viewing the eclipse wherever you are. You can cause serious damage to your eyes if you don't take precautions while watching. And there are a lot of people watching. As you can tell, the festivities, just like the eclipse, are in full swing. I'm joined by Chief Park Ranger Susan Cook.
Hey, Vince, how are you?
Thanks for joining me today. Great, Susan. Thanks for joining me today. Please tell us about this amazing place and what's going on behind us.
We are at Homestead National Monument of America. We are a national park site dedicated to telling the story of homesteading. 30 states, 10 million people, 10% of the United States was homesteaded. The head of a household, anybody could own land as long as you could be a U.S. citizen. You got 160 acres. It's how we settled the West. We built our democracy. We built our economy, settling the West through the
That is just so interesting. Now, I understand the Mayan calendar followed the solar eclipse calendar closely. Is that correct?
It did. The ancient Mayan used several different calendars to organize their secular and spiritual lives. Many of these calendars had strong roots in the motions of celestial objects, especially the sun and the moon. And the Hab calendar is a solar calendar of 365 days, subdivided into 18 months of 20 days, plus 1 month of 5 days. Another calendar is a Zolkin, made of 260 days, subdivided into 13 months of 20 days. This calendar also has a resonance with eclipses, which occur about every 173 days. Every 3 sequences of eclipses aligns every 2 cycles of the Zolkin. Who could keep track of that, frankly? Who could keep track of that, frankly?
It's just amazing. It's just amazing. Now, as a Chief Park Ranger, I have to congratulate you. This is a fantastic venue. Tell us about some of the activities you have planned.
Well, actually, right now you can feel it getting darker, but we have stage performances going on. We have many NASA scientists. You can learn about planetary defense, how we defend our world. You have NASA scientists doing other things. We have Native Americans. We have a Mayan calendar sky program. We have folk music. We have
lots going on.
Lots of things. Balloon launches. So there's things all around us. It's really exciting and a lot of fun.
Gotta say, the amount going on here, Susan, is incredible. Thank you so much.
Thank you very much. Thanks for being here.
Absolutely. And we're lucky enough to be joined by a real NASA scientist. Let me introduce you to Dr. Nikki Fox. Great, Nikki, thanks for joining us. Nikki is a space weather expert and a mission project scientist on NASA's Parker Solar Probe program. Thanks so much for joining us, Nikki. Today is a great day for you. Tell us why.
Well, today I'm really excited. This is my first ever solar eclipse, and it's the only chance that we can see the corona with our naked eye. And I'm particularly excited because I'm working on NASA's Parker Solar Probe mission, and we are going to fly into the corona. So if the clouds part here, you'll be able to see where our mission is flying.
Just incredible. Now, how close will you get to the sun?
We will get to within 4 million miles, and I know that doesn't sound terribly close, but if I put the Earth and the sun apart on a football field, then we would be at the 4-yard line.
That's just amazing. Now, for you watching at home, that's kind of like traveling from Washington, D.C. to Philadelphia in about 1 second. Just incredible speeds. Now, how can you get so close to the sun and not burn up?
So we have a wonderful heat shield, but we also, the technology, it's been 60 years since this mission was first thought of, and it's only now that technology has caught up with our dreams.
That's just amazing. Now, it looks like we're coming up to the moment of totality here on the prairie. What are some of the things we should be looking for?
So if it clears, you should see a beautiful corona, and that it looks like a pearly, hazy crown around the sun. And in fact, it's called a corona because that's Latin for crown. And then as it's going beautifully dark here, it's becoming twilight. You hear everyone going crazy here. You should be able to start seeing stars, and we can actually see 4 planets. This time you should see Jupiter, Mercury, Mars and Venus all in this night sky during the day. So it's just an amazing, amazing experience. And if you can't see the corona, I do have a map of it here. This is a 3D print that was done for me, and it looks exactly, it's a predict of what the corona looks like today. So if it's cloudy, here's your corona.
Now it looks like the moment of totality is upon us. Let's just let the guys at home have a few moments to take in the sights and sounds of the crowd as totality happens on the prairie.
And you can see the corona, and I may cry, but you can see the corona. So now you're seeing this wonderful hazy atmosphere. I need my glasses now, Vince, because we are in totality. This is the only time that it's safe to look. But right now you can see that hazy ring. That is the chromosphere. It is looking a little bit sort of reddish, and you just see those red wisps are little prominences that are coming away from the sun. Unfortunately, we can't quite see the stars yet because of the clouds. But my goodness, you can see the corona, and that is an absolutely incredible sight. It really is. Everything's kind of, well, other than the people hooting and hollering here, everything else has gone quiet. The animals think it's nighttime. There's this amazing sort of twilight view all around us. And just look at that corona. That is incredible. Absolutely incredible.
Yeah, that's amazing.
Yeah, and the moon is going to continue. We've got about 2 minutes 35 seconds of this amazing view, and then here we come. Here comes the diamond ring. So it is glasses on again time. Glasses on, and here it comes. There's the diamond ring. The most spectacular sight.
That's amazing.
It's just incredible. And of course the diamond ring you see because the moon is not a totally smooth sphere, and so you're seeing little spots of light peeking out between the craters on the moon. And my goodness, I'm sorry, I'm so excited. It's incredible.
It's hard to convey it's hard to convey the excitement of the energy. There are 10,000 people on the prairie here at the Homestead National Monument of America, and the energy is just amazing.
A lot of them have been here since 6 o'clock this morning, and the atmosphere has been incredible. Everybody is happy. It has just been amazing.
That's just amazing. That's just amazing.
Wow.
Okay, Nikki, let's bring you over to this side. It looks like the moment of totality has passed us here. Now, what should we be watching for in the moments after totality?
In the moments after totality, you will start to see again the Bailey's bead. So we did see that diamond ring, and I got super excited. But as the moon continues now to pass away, you'll start to see the solar surface come back. It's becoming light again. If we had any roosters here, they would actually be crowing. So it's amazing, and you'll start to see the sun coming back. And I don't know, I always think what it would have been like if you didn't know the sun was going to come back. You just thought it was disappearing, but here comes the sun again. So it's a wonderful, wonderful day here on the prairie.
Wonderful. Nikki, what an amazing experience. Thanks so much for talking us through that.
Wouldn't be anywhere else, Vince.
Thank you very much. Thank you very much. What a great experience, everybody. What a great experience, everybody. That is amazing. It looks like things are starting to calm down here on the prairie, but that doesn't mean the show is over. Our coverage of the path of totality continues across the entire path. So let's go ahead and send it back to NASA's Eclipse Central.
Thank you, Vince. Thank you, Vince. It was well worth the wait, my friend. We were a little delayed there, but my goodness. Did you see that? Jody, did you see that? I mean,
that was amazing. Do you see that diamond ring?
It was even more prominent there.
It was very prominent. You could see like the ray of light, like very, very nice, and the whole diamond around the whole surface. It was amazing.
And Alex, it got really dark. I mean,
it really did. That's actually enjoyed seeing them out on that prairie and seeing. It looked like she was in some sort of weird, strange light. She was lit up, and everything behind her was dark. It was really cool.
Nebraska, you rocking the house. We really appreciate that. But like Vince said, there's a lot more to come, and we got the International Space Station. Don't forget. So, Jody, I want to go back. You know, we had to bring in those images, but we were talking about, and you mentioned the stamp. Now, the United States Post Service, they do amazing work.
They do.
But they really outdid themselves this time. Go ahead and finish.
They did. They actually created a special stamp for this event. It's actually a thermochromic stamp, which means that it gets activated by heat, and you're actually looking at it now in your images. This stamp, if you put your thumb into the center, it will actually make the moon surface appear, or any type of heat that you apply to it. It's an amazing stamp, and I got mine yesterday, thanks to Dwayne.
And it's thermochromic?
Yes, thermochromic, yes.
Wow.
It means it gets activated by the heat.
Yeah, heat of your thumb.
I bet you they sold a lot of those.
I bet you they sold a lot of those things.
Oh, they did. They sold out online originally right away. So it's quite a popular one. It's the first time the U.S. has ever used that type of ink.
So we have seen some pretty cool images. Still got some more to come. The diamond has been prominent. Let's go over the social and see how things are going.
John. We'll continue to look up here in Charleston, South Carolina. There are some clouds here, and we're excited. Excitement we want to have here too as well. Just a couple quick interesting things. This is the biggest live stream event ever measured on NASA.gov. The web traffic is accounting for 87% of all federal web traffic, which is pretty amazing, showing that people are really tuning into our broadcast here. As of 1:40 p.m., 4.4 million people climbing or watching this broadcast. So the interest across the country is obvious here, and we're going to continue to show you some amazing live views. This right here is, again, another photo of the space station taken by Bill Ingalls in Washington, one of our photographers here at NASA. Next thing, I have a video from another photographer, one of our other photographers, as the space station transits. You can see it there. If you're looking closely, you can see the space station transiting the sun during the partial eclipse. Pretty spectacular. Again, that's 250 miles per hour, that space station. You have to be, 250 miles above the Earth, 17,500 miles per hour. You have to be taking a lot of different shots pretty fast to capture that. So nice job, Joel.
Okay, so let's go to Jefferson City. The moon shadow is continuing to pass over the United States in this remarkable celestial event. Our next stop on the path, as I said, of totality is Jefferson City, Missouri. We're going to hand off to meteorologist Eric Aldrich, who is a professor in atmospheric science at the University of Missouri. He has some special guests to help explain two important impacts solar activity can have on humans and the technologies we use. Over to you, Eric.
Okay, thanks a lot. Yeah, we are live in Jefferson City, Missouri. Jefferson City is actually the state capital, and as you can see behind me, there's a lot of people that are here. It's been a whole weekend type of thing, Saturday, Sunday, and of course here on Monday, lots of family-friendly things. There's been corn mazes, there's been 5K runs, there's a lot of good food. Too bad you can't smell the food, but there's a lot of good food that's here as well, and just a very nice weekend. The weather has been perfect. We've had some showers and thunderstorms off to the west all morning. We've had a few high clouds kind of stream on in, but certainly things are looking really good. I am lucky to be joined here by two special people that are going to be talking about space, weather, and just how things work in space. Dr. Janet Kavandi, thank you so much. You are the director of the NASA Glenn Research Center in Cleveland.
Right.
You're also a three-time shuttle astronaut.
That's right.
And you are actually from Springfield, Missouri. So welcome home.
Thank you. It's great to be back.
Well, great.
Yeah.
So now, we've been talking a lot about safety, and obviously you don't want to look right up at the sun.
Not without these.
That's right. And so we all have some, so that's good. But what about the astronauts that are up in space? What is there to help keep the astronauts safe from the solar radiation and so on and so forth?
Well, for their eyes, we know that they know that certain windows they should not look out of because there's no protection. Other windows have protection on them that help shield their eyes, but also there's other kinds of radiation like protons that come from the sun, heavier particles that can cause damage to our cells, and we try to shield the astronauts as best we can because they're above the atmosphere. We're shielded here by the atmosphere quite a bit, but above that you don't have that natural shielding, so we have to do it with metal in the vehicle and then some water bags around the sleep station so they can sleep surrounded by water, and that also helps absorb some of that radiation.
Okay. Now, we also are kind of excited about space communications, and that's certainly another special research area. And so also with me here today is Dr. Tamitha Skov. Now, you're from the Aerospace Corporation in Los Angeles, so welcome to Central Missouri.
Thank you.
Now, you're also a space meteorologist, and you are also referred to as the space weather woman.
I am.
Right? So I've been intrigued by this. What exactly does a space weather woman do?
Well, most people don't realize that the sun actually has its own unique weather that comes from it. And those solar eruptions that come from the sun, they actually hit Earth and cause issues for us. So I actually do a weekly broadcast, weather predictions, just like you do, like a meteorologist, that talks about when these events hit Earth and the types of issues that they cause for things like communications, like GPS and other systems.
Okay, now we're just about 15 seconds away, actually, I believe, from totality.
Put our glasses on.
So we're going to put our glasses on. You can hear the crowd cheering in the background, and it is getting dark.
We're getting close to Bailey Beads. Here we go. We're almost at totality.
And
you can see
here
the
we go.
Beads is almost the diamond ring right there. And there we go. I think we're at totality. So now you can take your glasses off.
That is amazing.
Listen to that. You can actually see the corona a little bit even through the clouds.
That is incredible. Now, Dr. Cavande, you've been in space. You've seen numerous sunrises and sunsets from the space shuttle. How does this event compare?
Oh, this is completely different than anything I've seen before. I never saw an eclipse. I've seen a partial, but nothing like this. This is really unique and nothing like I saw in space. Space has its really cool visuals, but this is really amazing.
You know, and I'm starting to hear the crickets. They're starting to come on out. Obviously, the street lamps. This is just amazing. Now, I'm also looking up to try to find the Big Dipper and some of the other stars, some of the other planets.
Not for the clouds, likely.
Right.
And I'm really mesmerized by this. This is a spectacular event. We've had several solar storms that have been launched, and some of them have been launched from the left side of the sun. So we're actually seeing a difference from what the corona looked like in our predictions to what it looks like now. And then on top of that, we have ham radio operators all over the state right now who are making contacts that they haven't been able to make because the upper atmosphere is just all turbulent right now, and it affects the communication signals. So we've got GPS operators and ham radio operators doing a ton of science, and it's just so overwhelming.
This is amazing. Now, my team of atmospheric science researchers from the University of Missouri, they are actually sending up weather balloons here this afternoon to try to figure out, how the weather is changing at certain height levels. And actually, here's a map of the solar radiation throughout the state of Missouri, and you can kind of see how much solar radiation is hitting the surface of the Earth here in Missouri. Just interesting. This is amazing.
It is. You can tell the crowd is just mesmerized. This is so cool. And you can even see the dips in the valleys, as you can see little areas of the sun where it's shining through more.
Right, and those create the Bailey beads that we'll see as we get out of totality, which is coming up here pretty soon.
Right.
Not quite yet, though.
Yeah, I think we come out of totality at 1:15:35 local time, and so we just have a few more seconds of that. It's absolutely an amazing event. And again, we're so lucky that some of these high clouds were able to kind of fall apart a little bit so we could experience this.
For us, yes. And I can't believe we can actually see the corona through the clouds.
Good.
Okay, that's the air horn. We're coming out of totality. We're going to have to end up going.
So we need to put our safety glasses back.
There we go. Put your Bailey beads. There we go. We got to put the glasses back on. Oh my goodness.
So, as you can see, we're coming out of totality here in Jefferson City, Missouri. Ladies, thank you so much for experiencing this with me.
Thank you. Quite an experience. Thank you very much.
Thank you. So, everyone's excited here in Jefferson City, Missouri. The sun's starting to come out a little bit. We're going to go ahead and send it back to Charleston.
We should have stayed.
Thanks, Eric. Yadi, wow.
It's an amazing, I get goosebumps every time I see this. So I cannot imagine how it's going to be, when we actually see it here in South Carolina.
I mean, so Alex, I'm speechless, man. I mean, as a scientist, you got to love this stuff, right?
Oh my God, and it's so great to hear them. I mean, I love hearing an experienced astronaut talk about how overwhelming it is, given the amazing things that she has seen, but also to hear my colleague, Tamitha Scove, who is also a heliophysicist and a space weather expert. I can hear the excitement in her voice. It's palpable. It's just great.
Okay. So check this out, guys. I mean, I think things are going so smooth. We're going to go to another image right now from Hopkins Girl. Brian Massey out there from Marshall Space Flight Center. What's going on? You got some action there. Hopkinsville. There it is.
That's beautiful. They're getting close.
Now, it's yellow. We had purple. Does that mean something there?
Well, the previous one we saw that was purple was calcium K. It was a blue kind of light. This is actually more of a white light, continuous. But the thing to remember is sometimes the different filters you use will change the color just a little bit. But what we're seeing here is really more visible, broader spectrum white light.
Okay.
White light.
Let me, John, you got to have some cool stuff on social media.
This is a good question, guys. Mark from Facebook's asking, and this is what really applies right now. When observing the moon at night, I see it proceed from eastern to western horizon, much like the sun does. How come the solar eclipse is traveling from west to east across the U.S.?
Well, again, that's because when we're looking at the moonrise, that's actually because of our location on the Earth and the fact that the Earth is rotating from west to east. The same reason that the sun rises in the east and sets in the west. But the moon itself is moving in the same direction the Earth is rotating, and it's casting that shadow down on the Earth, and that is moving in the direction that both the moon is orbiting and the Earth is rotating. So from west to east.
Okay, so the total eclipse has now passed over half the country. It's currently over Illinois, and I think we're going to have some views coming up shortly. But what I really want to do here, guys, is this has been really incredible. I want to give a shout out to the College of Charleston. Make some noise. Yeah! Oh, we're loving it here. So now we've got live video coming to us from Hopkinsville, Kentucky. It's a small town that's known for southern hospitality, like Charleston, and it's also a prime spot for viewing this total solar eclipse. Hopkinsville is the city with the longest duration of the total solar eclipse, for a total of 2 minutes and 40 seconds of totality. NASA's Marshall Space Flight Center, Brian Massey, I'm so excited. What you got, man?
Dwayne, we're just as excited as you are. We are here in Eclipseville. Say hello, everybody. Oh, we're having a great time. I'm surrounded by 1,000 of my best friends. We're getting ready. It's starting to get a little darker already. We're also joined here by NASA Marshall planetary scientist Renee Weber. Renee, thanks for joining us.
Thanks. It's really great to be here. I just want to say thank you to the city of Hopkinsville for having us out on this beautiful farm in Kentucky, and we're just all really excited.
Yeah, definitely. It's a lot of fun. This light's starting to fade, and the excitement's getting bigger. We are at the point of greatest eclipse here at Hopkinsville. Renee, tell us a little bit, what's the significance of that?
Well, the point of greatest eclipse is actually a point in time when the axis of the moon's shadow is pointed most directly towards the center of the Earth.
Great.
So we are at the point on the surface of the Earth where that time occurs.
Exactly. The shadow will actually be more circular here than anywhere else in the country, correct?
That's right. And it's getting really dim, and we are just so close. It's incredible.
Yeah, this is amazing. We can't wait to break out in the darkness. We've got our glasses out. We've been looking up at it. You can see now on the screen our live telescope view, and this is just amazing. Everybody is really enjoying it. We've got people from all over Kentucky, people from all over the world have joined us here, as this is Eclipseville, USA, and we are just a few minutes away from total totality. But before we get to that point, Renee, tell us, you're a planetary scientist and you specialize in the moon, a lunar scientist. How does the eclipse really speak to what you do?
Well, it is pretty cool to look up there, and when you're seeing that sun get dimmer and dimmer, it's because the moon is up there. Right. And I like to tell everyone that you're really looking at the moon when you're watching a solar eclipse, and it's just getting dim, and it's starting to get a lot cooler too. Yeah, it's incredible.
Crazy. This is my first solar eclipse. Renee, have you ever experienced one?
This is my first total eclipse too. I've seen partial eclipses, but I've never had a chance to see totality before, and I'm just so excited.
It's amazing. The light is starting to fade as the moon steps in front of the sun here, and it's already just a really eerie feeling here, getting dark in the middle of the day. But we're really excited about it, and we're just a few seconds away. I've lost my counter, but I'm going to look back at the sun while I still have the opportunity. Wow, that is absolutely amazing. We're down to just a thin sliver of the sun. Renee, what do you think about this?
I can't believe it. It's just, it looks incredible, and it really is starting to get dim, and nobody even needs their sunglasses, just your eclipse glasses, and you can see that beautiful crescent sun.
Wow, this is absolutely amazing.
We're just really looking forward to that for a chance. We got no clouds here in the sky, and you can see some airplanes up there, but that sun is just getting smaller and smaller.
Yeah, it's definitely a Hopkinsville, Kentucky Chamber of Commerce sponsored day here in Eclipseville. There's not a cloud in the sky, and it's amazing how it's gotten so much cooler here since the sun started covering up started being covered.
Yeah, it's nice to have a break from that hot southern sun.
Yeah, definitely. We've been sweating it out a couple days here in Hopkinsville getting ready for this.
We're getting really close now.
So what exactly are we looking at here, Renee?
Well, we're just about close to 100%. It's just getting smaller and smaller, and it's getting dimmer and dimmer, and hopefully soon we'll have a chance to see those Bailey's beads and that diamond ring.
Right.
That's when you can actually see the light shining through the moon's valleys. The moon's not a perfectly smooth sphere. It's got that rugged surface, and you can see those sun rays shining through those mountains and valleys and craters.
Wow.
It's looking like we're about 1 minute out now, and it's just getting smaller and smaller.
Wow, this is amazing.
The crowd's getting really excited too.
Hey guys, who back there is excited for the solar eclipse? Wow, it's getting closer.
Wow. It's just getting really close to nighttime. It's incredible. It's like very dim.
Definitely it feels like dawn or dusk here in Hopkinsville right now as it's getting closer.
Come on!
And you can see on our feed, there's that tiny, tiny little sliver left to go. And it's really starting to get dark now. Wow. It's
Goodness
like dusk.
gracious.
And you can see the pink color around the horizon. Oh, it's like a sunset. It's beautiful. It's going. It's going. Just that tiny, tiny last sliver. Oh, my goodness.
And we are in total solar eclipse, and this is absolutely breathtaking.
Yeah, you can see the corona, that beautiful white wispy crown coming out from the sun in all directions. And we can see airplanes, and I think I see Jupiter in the sky over there. I think I can see Jupiter.
Wow.
And I see other planets too, and stars.
I can only imagine in ancient times what this must have been like.
I know.
Out of nowhere. I am covered in head to toe in goosebumps. A complete chill.
I know, I am too. I just can't believe we finally got a chance to see it. I mean, it's one thing to read about it, but it's another thing when you get to see it yourself with your own eyes.
Guys, we're going to take a break here just a second. We're going to step back and fully enjoy this and hope you enjoy our feed on the telescope. Wow, here in Eclipseville, it has definitely lived up to
And now we're getting that diamond
ring. Here we go. We've got it coming back. The moon is stepping aside from the sun. It is getting brighter. Totality has finished here at Hopkinsville. Wow, that was absolutely amazing, Renee. Can you even try to put it in words?
I can. I mean, I just have goosebumps all over my body.
Can you even try to put it in words?
I can. I mean, I just have goosebumps all over my body.
Wow, this is amazing. We can see the birds flying around in the distance.
We can see the sun starting to come out, and it's getting bright again.
This is amazing.
It's really a once-in-a-lifetime opportunity. Until the next eclipse that we'll have only 6 years away. We get to see it again.
Wow, we'll be there.
Yeah.
We will be making our way.
I think I'm hooked. I'm an addict.
We have sat in meetings preparing for this for the last 2 or 3 months, and now that it's actually here, it's completely 100% lived up to its billing, and I can't imagine, I can't believe what just happened.
It was just amazing. We were so worried about the weather and the broadcast and making sure our telescope was set up and everything went smooth, and we just had a blast.
Wow, this has been absolutely amazing. Folks, we have really enjoyed it. It's been a great time here at Hopkinsville, here at Eclipseville, USA. Now time for us to send it back to Clarksville, Tennessee, where our good friend Chris Blair is standing by for their reaction to the eclipse. Chris?
Well, I think he meant Charleston, not Clarksville. So let's bring it back here at Eclipse Central. There's only one Eclipse Central, and it's here in Charleston. Yeah, okay, so the hits just keep on coming through the eyes of NASA. Now, let's continue. Now, these are going to be pre-recorded views from the high-altitude WP-57 aircraft. They soar high above the clouds that could potentially block the views of today's eclipse. And they're chasing the total solar eclipse. They're mid-wing, long-range aircraft used to conduct high-altitude research. So, let's go to these pre-recorded views.
Yeah. Yeah.
Okay. Yeah. What are we seeing here, Alex?
So right now we're looking at these specially fitted cameras. They're on the nose cone of the WB-57, and these are designed to look at the corona, and they're also designed to look at Mercury. They're taking thousands of images every minute and processing this data to give us an extended view, because up there at 50,000 feet, it's 20 to 30 times darker than it is here on the Earth. Here on the Earth, there's a lot less scattered light. So this is a really unique opportunity. As those two planes fly in tandem, they give us about 8 or more minutes of a view of the corona. Now, the other thing they're actually looking at is, because they're so high up, it's very cold, and that allows them to take infrared observations. And in this case, Mercury is very close to the sun, and they can take infrared observations of Mercury to see the temperature change as Mercury is rotating.
That's amazing. So we're going to come back with that, but let's go now. Let's go to Clarksville and see what's going on there.
All right, thanks and welcome back. We're excited to highlight some of the student science and the STEM aspect of this solar eclipse. We have several students joining us right now. Would you please tell our audience your name and what school you go to?
My name's Eliza Dellert. I'm from the University of Alabama, Huntsville.
And what club or group are you with?
I'm actually with the Space Harbor Club.
All right, and you guys have been launching balloons all day today. Tell us about the scientific payloads and the instrumentation.
Well, on our first balloon, we had a Geiger counter counting alpha, beta, gamma particles. We also had a pointing payload to get stabilized camera footage along the way. We had some hops from one of our local breweries. And then we, on our second balloon, we had a live streaming payload. So that was cool. That was probably our biggest project, thanks to Alabama Space Grant and National Space Grant. And so we were really excited with all of our experiments. They went really well.
Excellent. Well, we're glad you came here to do this. We appreciate it.
I appreciate it.
Thank you. And so that's University of Alabama in Huntsville. And so we also have another student joining us from the Space Camp, U.S. Space and Rocket Center in Huntsville, Alabama. Tell our audience, please, your name. And I just said who you're with. So tell us your name, please.
I'm Stephanie Bonifield. I'm from Pittsburgh, Pennsylvania.
And you're with the Space Campers. What have they been doing all weekend long to get prepared for this eclipse?
Well, the day before we left, we did a whole bunch of eclipse stuff. We did classes about what the eclipse is and like what we'll experience, and a lot of safety stuff. They didn't want anybody like burning their retinas or anything, so we did a lot of that. We talked about what experiments we'll be doing. We set up the shadow band boxes that are over here that are out of the shot, but we recorded hopefully some interesting data about what was happening during totality, so that's pretty cool.
So you guys will go back and go over that data a little bit. Tell us about the students. Where are they from? It's not just students from Alabama.
No, yeah, we have students from all over the country and even all over the world. We have students just in my team who are from like Spain. We've got someone from Norway, all over the world. It's crazy. There's a girl in another group who's from Mexico and a boy from Mexico, and they were like talking to each other in in Spanish the other day, and that was really neat, just meeting other people from other cultures. So you really get a neat experience at camp.
Absolutely. Education is global. And so lastly with you, give us your first reaction to viewing the solar eclipse.
It's just really crazy. It is daylight here, and it was daylight before, and then the eclipse kind of comes in slow, and it's just like a glowing ring in the sky. It's incredible. It's so hard to explain. And then the lighting, it's not like dark like at night. It's like this kind of almost eerie sort of ambient lighting, and there's a sunset everywhere. And then after totality, like right after, it was like somebody turned daylight back on. The moon just moves away and it's light again. It's really awesome.
No, absolutely. It's exactly what happened. So thanks. We appreciate your time. Thanks a lot. So we got one more student joining us. It's from the Inspire Project. Please tell us your name and what school you attend.
I am Robert Allsbrooks, and I attend Chesapeake Math and IT Academy in Maryland.
And tell us a little bit about the science experiments and research you were working on while you were here.
I was working with the balloons, and I was also working with the shadow bands and the ham radio.
All right, and how about your first reaction to the solar eclipse?
It was just amazing. When I saw the sun go away, and it almost went pitch black, and I just looked up, and there was just a ring around the sun, and it was amazing. That's all I have to say.
I appreciate it. Thanks a lot.
Thank you.
On behalf of everyone here at Austin Peay State University and NASA's Marshall Space Flight Center, thanks for letting us be a small part of this wonderful event. Right now, let's go back live for continuing coverage of this eclipse from Charleston.
Thank you. We are having a great time here at the College of Charleston, but we've got more images coming here and the International Space Station later. Let's get some images coming in from the Great Smoky Mountains, one of the largest national parks east of Rocky Mountain. Wow. Alex, what is that? Looks awesome.
We're looking at the sun that's still too bright.
It's still too bright.
But it's almost completely covered. It's getting dimmer and dimmer. And this is the unfiltered sun. So we're going to go straight from this to seeing the corona directly. This is going to be a pretty cool shot, actually.
So here's still, glasses still on.
Dimmer. Still got to have your glasses on. It's still too bright to look at directly. But it's just almost like a little tiny Christmas star or something. It's crazy. It's getting tiny and tinier.
Now, why was it in the shape of a star? That's the first one I've seen.
That's oh, there it is. I can see the corona.
Oh, okay.
That's because the camera itself didn't have a filter on it. And it was too difficult to see. But we can see the corona. There's now a little black dot, and you can see the corona around it. And that's actually the closest to what we're going to see when we look at it with our own eyes, when we view it here.
John, let's go to social, man. They got to be buzzing on the conversation here.
Yeah, there's a lot of questions coming in. Of course, it's trending all over social media. Let's pull up this image right here on the sidebar, if possible. This right here is just one of our users did of the eclipse from Arlington, Texas. Pretty freaking cool. Showing the showing the partial eclipse on his hand, really interesting. And then we have the Toshiba screen in New York City, where, of course, everyone there in Times Square is able to see the partial eclipse. So it's pretty spectacular views coming in. And we do have a few questions. I'd like to just try to get a couple in. Is it okay to see a solar eclipse in selfie mode? I see a lot of people, there's students out here, and students like to take selfies. Is that without glasses? Is that okay to do?
Actually, it is if the sun's especially behind you, because if you're looking down, the sun's behind you, and you've got it in selfie mode, that actually will protect your eyes. Again, the main thing is you do not want to have it pointed directly at the sun so that you might move away and see it with your unprotected eyes.
Yes.
So let me use this opportunity to talk about safety reminders too, about just making sure, like you just said, it's the overall view.
You know, if you're in the partial solar eclipse, make sure that you always have your glasses on to look at the sun. The only time that is safe to take off the glasses is when you're all completely, like the moon completely blocks the surface of the sun in totality. As soon as you see that diamond ring effect, that's the timing to actually put back your glasses to look back at that amazing event.
And John, let's get one more social question before we go to the next phase here. We're just having too much fun here.
Starting to get cold and dark here, too, in Charleston. This is, I think this is pretty obvious by all of us outside right here, but is it safe to be outside during the eclipse as long as you don't look directly at the sun?
Absolutely. There's nothing different. We are just having less sunlight shining down on us, but there's no real difference, and it's absolutely safe to be outside. And we, of course, as long as you're safe, encourage that.
Yeah, go outside and watch this event.
Okay. All right, here we go. So, let's talk about exoplanets. A solar eclipse is a special kind of transit or movement of astronomical body that passes in front of another. And if you've been watching along with us, you know NASA is using today's transit to further study the sun. We use similar transits to study planets outside of our solar system, or as I said, exoplanets, as they pass in front of their distant star.
While a total solar eclipse is a rare opportunity to learn more about our sun, NASA's Kepler mission has been studying distant stars for an eclipse-like event called a planetary transit. Using a space-based telescope, scientists from Ames Research Center have been measuring the changes in the brightness of stars as their planets orbit or transit in front of them. Kepler has confirmed more than 2,500 exoplanets, or planets beyond our solar system. Many of these are similar to Earth in size and distance from their sun. Studies using Kepler data have revealed a vast range of planet types and sizes, and future discoveries could help enable the search for life in the galaxy. Another major effort at NASA Ames to use eclipses to study stars in deep space is called SOFIA, or the Stratospheric Observatory for Infrared Astronomy. SOFIA is a modified Boeing 747 SP aircraft that makes celestial observations in the infrared part of the electromagnetic spectrum. Flying up to 45,000 feet, SOFIA operates above 99% of the Earth's water vapor that absorbs most of the infrared light from space. One example of SOFIA's unique qualities as an airborne observatory occurred when researchers recorded infrared imagery of Pluto as it eclipsed a distant star. What we learn from missions like Kepler and SOFIA could help us to better understand the mysteries of our sun, our galaxy, and our place within it.
All right, thank you. We're here live at the College of Charleston in Charleston, South Carolina, where it is just about time for totality. And I'm here with my colleagues, Dwayne Brown and John Yembrick, and Jari is somewhere, I believe, Carla Vega, and Alex Young. And you can see the crowd behind us. And if you look up in the sky, which I was doing just before we came back here live, we are probably at about 90% totality. And the good news from the weather standpoint is there are some clouds, but I see some breaks in them just off to the south a little bit. And fingers crossed, really tight that those breaks are going to move over as we get into totality in just a few minutes. Dwayne, what do you have to say about that?
Well, first of all, I want to thank you for, hey, man, we got something. You are the man. You are the man. This is exciting. We've got our glasses. We got our scientist, Johnny. Come on, get in here, and Alex here. So we're excited here at the College. Make some more noise, College of Charleston. Yeah. We are having a ball here. There's still a lot more here through the eyes of NASA. We got the International Space Station coming up. You don't want to miss it. Now here we go here. Safety glasses on, guys.
getting there. Yep, we still got maybe a few more minutes to go till totality, but you can see. Look at that. You can see that. Yeah.
Wow. Johnny, you know, even with the clouds, we can still see it. It's pretty good, right?
You guys see it?
weather.
Oh.
We don't have that here today.
No, we don't, and it's going to be 7. So what can you tell us about the sun that'll help our audience understand better?
I just want to start by saying I'm in awe at this moment right now. And whatever I say, kind of take it with that filter because we are very close to totality.
We are.
We live in the outer atmosphere of this magnificent, dynamic, magnetically variable star that dominates every cubic inch of space in our solar system. And if I can get the video, what you would see in the video is that the sun produces storms that can be all engulfing, generating this environment called space weather. The inner edge of the corona that you see that's black in the video is because the sun is so intense that it overwhelms the dim brightness of the corona. And so even from space, we can't absorb the inner part of the corona. And not only Earth, but the entire solar system, as you can see, lives with this dynamic star. Corona is the region where space weather is born and conditions are set for a supersonic solar wind and a super hot corona, 2 of our outstanding questions in heliophysics, in physics, really. To understand the corona better, NASA is actually going to be launching a mission next year, almost a year from now, how coincidental, called Parker Solar Probe. It is actually going to go touch the sun, and it's going to get closer to any other spacecraft has gone before to the sun to study the corona, to actually sample the very corona that we will be seeing very soon.
Yes, we will. It's almost here. Thank you, Lika, for joining us, and thank you for sharing that. So now we're going to take it back to NASA Eclipse Central in Charleston. Take it away, Dwayne.
Okay, just now coming in, we have an exclusive sneak peek of the total solar eclipse, and it is arriving at the United States. It's over the Pacific Ocean and about to reach Oregon. This is the celestial event that we've all been waiting and anticipating for years. We'll begin looking through the eyes of NASA out the window of our G3 aircraft. Let's take in the view.
Wow.
And now we're looking at the first glimpse of the total eclipse from the ground. Wait, let's see. That's still the G3. There we go. And now we're looking at the first glimpse of the total eclipse from the ground on United States soil. This is coming to us from Salem, Oregon, where thousands of people are gathered and experiencing this monumental event, a total solar eclipse. Let's take a look and take in the view.
Oh my God, that's so pretty.
That's the G3 there. Is that the real thing? Is that the real? We're going to keep that up, and then we're going to do reactions. Okay, so
as the moon has now moved, the sun is appearing again, and we can see the diamond ring. It's amazing. It's fantastic. You see the outer edge. I see prominences, little red pieces of chromosphere from the lower atmosphere. This is amazing. This is absolutely amazing.
Jody, what we got? That looks pretty cool.
I mean, it's breathtaking. I just, even seeing it right now through the TV, it's just an amazing thing to see. I cannot imagine what we're going to feel here in South Carolina when we have our chance.
Well, I hope we have our chance to, you know, Sean, and, you know, get that weather up here looking good here in Charleston. Now, what do we...
So, Alex,
what are we seeing here?
Is that from the G3? That looks like from the G3 because I see spectra there.
No, it's still from Salem.
That's still from Salem.
Yeah.
Okay, so you're seeing the bright, actually the camera is causing a little prism effect there, and you're seeing the bright light from the edge of the sun. So that is really beautiful. That's sort of the edge of the diamond ring effect.
Yeah.
So, Alex, a reminder, Alex, so when that diamond ring pops up, that's when people should put the
That's when people should put your glasses back on. So when you see that diamond ring after totality, that's the signal to you that it's time to put it back on.
Yeah.
So look now, we see the corona in Madras. That's gorgeous.
That's amazing. I mean, being able to look at that with your own eyes is an amazing experience. And that only can be seen when you have this kind of totality.
So the corona, that's the
solar atmosphere.
That's what solar scientists really